Have you ever looked up in the night sky and wondered just how vast and unknown the universe can be? If so, researchers and scientists at NASA have developed the James Webb Space Telescope, also known as JWST, that can hopefully solve this problem. As a child, I always had a deep interest in space and would write papers about how to build a telescope and how to build a spaceship using my imagination around second grade. Nowadays, I keep up with current events of space discovery, like the first image captured of a black hole in 2019, and now, of course, the new images of JWST. The purpose of this speech is to inform everyone here of the current events of the new images captured from JWST, and I will begin by going into the technological advancements of the telescope and move on to the images retaken with it. So what just makes JWST so special? According to Royal Museum Greenwich, JWST uses red and infrared light to capture images, while the old Hubble Space Telescope uses visible and ultraviolet light. This is important because the infrared light is able to go past our visible barrier within our universe and capture images never seen before. That is because infrared light has longer wavelengths and is able to pierce through clouds and normal objects that visible light would be stopped by. The JWST telescope can see images 13.7 billion light years away, and fun fact, the images captured 13.7 billion light years away are in fact 13.7 billion years old. As light travels through the universe, it doesn't age and can get captured by the telescope and is able to show us the past of our universe. So by now, I hope everyone is interested in the capabilities and what the images look like from this telescope. Our first image can be found on the NASA webpage and is of the SMACS 0723 galaxy cluster. On the left is the image from Hubble, and on the right is the image from James Webb. Other than the quality difference between the two, let's dive in deeper and see what this image shows. This galaxy cluster is 4.6 billion light years away, and of course that means that it is 4.6 billion years old. And although this image may seem like it is from a large image in our night sky, it is technically the size of a small grain held arm's width apart. And maybe you guys didn't notice, but there is a slight curvature and arc of this image here, and that is because the gravitational force of this galaxy cluster is so strong it can bend light as it is being received from the telescope. So although this image shows a great quality that JWST can capture, let's see its infrared capabilities be shown. Our last image is of the pillars of creation that can also be found on the NASA webpage. And on the left here, just like before, is from Hubble, and on the right, it is from JWST. Hopefully you guys noticed that using JWST, we see newly formed stars that are showing through the dust cloud. That is, of course, because we are using the infrared capabilities and the light is passing through that dust cloud. Something also newly discovered are the lava-looking edges on the tops and tips of pillars, and those are actually excretions from newly forming stars. So, although the images I've shown you today are from past images retaken with JWST, imagine the new capabilities and discoveries in the future. So in the end, I hope that this speech has been informative and shown the impact that the James Webb Space Telescope has had on space discovery. And I hope in the future, new images are developed and show new stars and galaxies that we've never seen before. And I hope you guys now understand why space has been always so fascinating to me. Thank you.